So hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma, and today I am joined with Luca Palmieri.
Hello.
Again, I'm trying my best over here. Nice to have you on. So Luca Palmieri is a principal software engineer. Hopefully I said that correct. And a self-published author, right?
Yes.
And the reason I brought you on is because I wanted to talk about your book. Again, as I said, I apologize. I still haven't had a moment to read it. But of course, the idea of going from basically zero to production, as this episode is titled, is a awesome way to teach people, because I find a lot of books that kind of teach you the basics, or maybe teach you advanced stuff, but they don't take you from beginning to end, right? You have telemetry chapter. You have, I think you also have a testing chapter. At least I hope so. If not, shaking your head yes, so that means a yes.
Yeah, there is a telemetry chapter.
Because one of the things that people always miss in tutorials is how to test, and I came from a big testing background. So that's always great to have, and people always skip that. So anyways, let me go ahead and let you introduce yourself. I'm talking too much now. This is your time to shine, right? So go ahead.
Sure. So first of all, thanks for having me. It's a pleasure to join the podcast. What to say? I'm a software engineer. I've been working with Rust for a few years at this point. At a certain point, I decided to write what later became Zero to Production. So I try to think of it as you were saying, like a way to go from zero, so not knowing anything about backend development, to being able to write some good-looking code, more or less robust, that you wouldn't be embarrassed to see running in production in a serious business. And the idea, and what kind of made it popular, I think, was that we're doing it with Rust, which is a fairly new stack. There's not an established pattern to do some of the things we're doing. And so it's interesting because it puts together what is available into the ecosystem and teaches you how to use the ecosystem to actually build your services. So that's the pitch, I guess.
So what was like the whole idea about, like, why did you get started? You're just saying because there was nobody writing things, and so you just said, let me just handle this?
So it's a little bit more nuanced than that. So we were using Rust in production here at TrueLayer. We were starting to use Rust in production around spring last year. And at that point in time, of course, we didn't have a strong presence inside the company of people knowing Rust and having used Rust before, even more so about having used Rust in a production setting. And so what we needed was a way to onboard new engineers which had a background in backend development, but didn't know how to do backend development with Rust. And we couldn't find any resource out there which was a single point of reference, which we could say, okay, for the first couple of weeks, you go there, you read this, you internalize the content, and then you should be able to go and work on a code basis. But this just didn't exist. And so that's when the light bulb kind of went off, and I was like, well, if it doesn't exist, then this looks like a good opportunity to write one. So I put out an announcement saying, would anybody be interested into this kind of content? And it was received fairly positive. So there was like a strong reaction from the community saying, yes, I want something like this. And I started to write it one chapter at a time. And after enough chapters have been written, I was like, well, this actually could be a book. And that's how the book eventually came to be.
Now, was there any input from your employer or other colleagues to kind of help you out, or did they even know that you're starting this? Or
no, well, they didn't know at the beginning. They came to know afterwards. So then the book became actually part of our onboarding. So people join TrueLayer in the Rust teams, get a free copy so that they can get up to speed on how things are done. And it fairly mirrors the way we do things internally, so there's a lot of value. But it's kind of detached from my employer's responsibility. So it occupies most of my weekends, not my working hours at the time being.
So do they actually promote you to keep working on this book and kind of help you? I mean, it sounds like it because it's kind of like a training material, right? So I'm surprised they just kind of say, oh, we want to use it, or, you know what I'm saying? Like, it's almost like they're not taking advantage, but definitely, how would you say that? It's like they're using it as a training material, like you said, but they're not really kind of putting any support behind it, or are they? Or I'm just curious about that part, right? Because it seems like they're taking it as a training material, but then they're not really letting you work on it during your work hours, or do you understand my question?
Yeah, I understand where you're coming from. It's a different arrangement. Like what I need and what I get from the book being used as training material is feedback. So knowing that there are like readers going through it in detail and providing me with feedback on how that is going. And being the book self-published, that for me is extremely valuable. And in the greater scheme of things, it doesn't matter if like 10 or 20 copies go out as training material internally. I'm actually happy to provide them. In terms of like being in between working hours and outside working hours, this is something I profit from. So like I retain the AP of what I'm doing, and so it wouldn't feel fair to do that within working hours.
Yeah, that definitely makes sense. So how did you guys manage to, so you're saying like there's no material out there to kind of bring people up to speed and good patterns and things like that. So did you guys discover these patterns based on reading from other people or experimenting? Or, how did you guys come up with the proper patterns that you think really work?
So the idea is that you never start from scratch, right? So you start from the experience you built in other programming ecosystems around different languages. And then you try to translate some of those patterns into Rust and try to find the most idiomatic way to actually make sure that those things work. So we didn't have to invent the fact that there is benefits into doing test-driven development. What we need to find is what's the easiest way to write an integration test. The same around doing input validation. Like that's something you do in every language. Like what's the most idiomatic way of doing it into Rust? And you say, okay, well, Rust is very fairly advanced type system. So we can learn from how Haskell does it. So we do when code constrains it to types. And that's where we do input validation. Authentication, deployments, tracing, all these things are constants, which are part of the domain of backend development. So what you need to do is just find the most optimal way of representing them into Rust. And this has been, of course, an iteration journey. So part of it is like collating previous experience that exists within the ecosystem. So looking at other talks, looking at articles, looking at open source code bases, and try to get a sense of this works, this doesn't work, this might work. The other one is us working on our own stuff and saying, okay, we actually think this pattern is the way to do it. And then extrapolating that and codifying that into something that others can use. So it's a mixture of both.
Yeah, that definitely makes sense. Okay. So was there anything that you guys started using and then you found out wow, this is totally the wrong thing? Like it could be that maybe you set up some kind of pattern and then this was working, but then after some time you're like, wait a minute, if we keep going down this way, we're going to be in big trouble. We should really try this other way.
Massive mistakes, as in never do that again. I don't think we made any. At least not that we know at this point in time. We might find out later down the line. There are things that we iterated upon massively over time. So I can think about the way we structured event sourcing, which is something we don't touch in the book, but how to structure complex state machines and how to make sure they work. This is something that we, I think, went to 3 or 4 iterations at this point. It's something that is not touched on the book yet. It's going to be one of the chapters that is going to come out in the next couple of months. But it took a while to find the right compromise between static checking, so making sure that things are checked at compile time, and ergonomics, so making sure that it's not awkward to use those types and actually write those functions. And it's something that comes up over and over again, because in the end, in backend development, most of what you're doing, there's a bunch of translation. So you have translations from stuff coming over the wire for incoming requests. There might be REST, gRPC. There might be messages on some bus. Now you have translations at the bottom. So stuff that's getting stored somewhere with multiple different type of storage backends. And you have this kind of kernel, which is business logic. And the business logic is usually around objects which have a lifetime and an identity. And these objects usually have states, and you're trying to control the way they transition between these different states. And so that core loop is something that you want to get right, or you want to have strong indication on how to do it, depending on how complex that is. And so that took us, I think, a little bit of iteration to understand. In the end, as I was saying before, we standardized very common patterns in other languages. So hexagonal architecture is something we use pretty extensively. And so that we found out works very well in Rust, as it does in .NET or other programming ecosystems. And that allows very nice decoupling of concerns. So you can iterate then on the specifics. So now you do the different parts pretty much independently, which is nice.
Okay. And I was kind of curious because you guys are using Actix, right? So I think most people nowadays are switching over to Warp, or at least starting off with Warp.
Are they? I don't know.
So that's what I don't know. That's what I read in a book recently. And well, the thing is, because Actix doesn't use Tok.io, or does it use Tok.io?
Actix is built on Tokyo, yes. There's a wrapper on top of it, but it's like the sugars to Tokyo underneath.
Okay, I thought it wasn't. That's what I'm trying to figure out. Like, to me, the hardest thing I really cannot figure out is like, I understand that there's different. Do you call those like async backends or async engines, or what do you call those like Tokyo?
Usually call them async runtimes.
Yeah, async runtime.
There's like different choices depending on the context, but yeah.
Yeah, I was kind of curious about like how come Rust never had their own like built-in async runtime. But it seems like they just want the community to choose because I guess it depends on your use case and what kind of guarantees you want, right?
So I'm not big on the lower level details of async await, but at a high level, what I would say is that there's an experimentation phase. And I think what the standard library did, the standard library took in the minimum amount of interface required to make an async await ecosystem possible, and that was the future trait. Now, at this point in time, when building on top of that future trait allowed an ecosystem to grow and become successful to an extent. Now you're feeling the pain of multiple executor implementations. And the pain is not really that there are multiple executors. I don't think that's really what like the friction is coming from. The friction comes from interoperating between those multiple executors and the way the executor bleeds into the libraries that use it. So can I write a library, for example, for doing an HTTP client that does not have a strong connection, a strong coupling to a particular executor? At this point in time in Rust, this is kind of complicated because we're missing primitives. For example, how do I spawn a task in a background? These things do not exist. I know that a focus of the current async exercise. So I think Nico Matsaki was like putting forward a vision repository with like use cases and pain points that we're planning to address, and interoperability between executors is one of those. But at this point in time, there's like a strong incentive if you don't want to spend too much time like debugging weird bugs in corners of your binary, to stick to one runtime and make sure your old stack of libraries works well with that runtime. And then in our case, given that it's the most popular and is the one used by most of the libraries we wanted to use, we stuck with Tokyo.
Do you know why that one is the most popular? I am kind of curious, and I don't really know of any.
First and foremost was the first one. So when you have first mover advantage, Tokyo's been around, I think, for 3 or 4 years at this point, since the very beginning of exploration into the async await for Rust. And is also extensively used in production. So it was extensively used, for example, in Linkerd, which is a service mesh for Kubernetes. So it gives you a certain type of, peace of mind.
What was the first piece that you guys actually started building when you started working with Rust? Because I think if I remember before, you were in another podcast or something recently, I'm listening, and I think you guys were using, was it Python before you switched to Rust? I can't remember what the language was.
We're using C#.
C#, it was .NET then.
Yeah. So we're using C#. That was our main language for everything backend here at Layer. We decided to give Rust a go because we were starting to write a new product, which had slightly higher security profile. So we were looking into basically managing bank accounts on behalf of customers. So not really bank accounts from a regulatory perspective, but from like a conceptualization perspective, you have a balance, you can move in money and move out money. So from like the man on the street terms, it's a bank account. And of course we had to build a ledger, and like there was a lot of like corner cases. We wanted to make sure we were doing this right. And what we didn't like from C# was the lack of errors values. So exceptions proved to be over and over and over again for us a very difficult to solve pain point when building services with the objective of those being reliable and behaving predictably. Because exceptions are inherently non-local. So you have a function that you're calling, the function signature covers the inputs that the function is expecting, and it covers the output that the function is going to return in the happy case. It doesn't tell you what's going to happen in the unhappy case. So you either go in and read the implementation and figure out what exception is going to raise, or you look at the documentation, hoping that that is up to date. But in truth be told, like the function can change in a semver compatible manner, but the function can stay the same, but the package can change and the exceptions may change. And so it's very, very difficult to make sure you have an iron-tight error handling story, especially when you're building a fairly complex piece of software, which has like multiple layers. And you want to make sure that each layer is handling the exceptions correctly and like recasting them and encapsulating concerns. Like it's always like it feels you're swimming upstream. Like it feels like the tooling and the paradigm is working against you in actually making sure that things are handled as they should be handled. Rust provided us errors values, which was a great step forward, and provided us with enums with values, so algebraic types, instead of moving like classes and inheritance. And so those two things together like were a much better foundation to build domain code and actually modeling a domain. And so we decided to give it a go, given the importance of what we're trying to build. And it worked out fairly nicely. So then we extended the usage of Rust quite significantly, and it's roughly 1/3 of the platform at this point in time.
Yeah, I like the what you're talking about, right? That definitely makes sense. The question is like, yeah, if I get an exception, what do I do, right? And how do I handle it? This kind of question. I come from more of an Elixir background, and Actix definitely speaks to me with you have this idea of actors and supervisors, supervision tree, something like that. Can you talk more about Actix and actually how it works at a high level? Does it? I know it does have supervisor, but does it have like a supervision tree, I'm guessing, where you can kind of have like a start and end?
So there's a little bit of historical baggage here. So Actix Web started as being built on top of Actix, where Actix was an actor framework. And so that had like supervisor and actors and messages and inboxes and all those sorts of things. And at a certain point, I don't remember exactly if that was Actix Web 2 or Actix Web 3, it actually stopped being built on top of an actor-based framework. So actually Actix Web is its own thing and Actix is its own thing. And so Actix Web has a much simpler architecture from this point of view. So it's basically, there's a bunch of workers, one worker per thread. Each workers do not share any state. So each of the worker is sharing nothing with the others. And as requests come onto the connection, they get dispatched to the different threads. If one of the workers dies, it gets respawned. So you might say that there's a supervisor from that point of view, but that's pretty much where the similarity ends. So from like a user perspective, Actix Web is simply like a web framework at this point in time. So it's way less actor-based as you might have, for example, Phoenix in the like Elixir land.
Yeah. That's what it sounds like. It's a simpler one. So what kind of things does Actix Web give you, and doesn't give you, right? So like if you're talking, it sounds like you already know Phoenix, right? So Phoenix, you get server-side templates. You can easily add in like the live view. You get a database connection. So what actually is included inside Actix Web in terms of like, yeah, I'm guessing, is there actually a backend templating thing, or that's something you have to roll your own or pull in yourself?
So this is just this is more of a general topic for the Rust web ecosystem. Rust web frameworks are fairly skinny, so to say. Like they give you mostly like a typed interface around HTTP request handling. So they're usually built on some kind of framework, sometimes like server at the bottom, which is more often than not Hyper. And then they provide you a nice API to kind of run middleware and like get hold of the request and then provide a response. We don't have something along the lines of a Django or Rails where you're like, okay, I'm going to provide you a comprehensive approach to how you should be building an application. And I'm going to be providing you with a bunch of like high-level opinionated components on how to implement a SQL store on how to implement authentication, on how to implement a login page, a sign up, all these kind of things. And I think this is mostly a function of the age of the ecosystem. So the ecosystem has really started, in quotes, when async await it's stable, which was 2 years ago. And since then, has been iterating quite frantically. So there has not been a lot of time where things have been stable. And the different pieces in the ecosystem are also highly experimental. So like 2 years ago, you didn't have SQLX, or SQLX was like just coming out. I would have to check the dates. So a lot of things are like in flux. And I think there's like a little bit of pushback from maintainers to actually like jump the fence and say, I'm going to do something which is like Rails for Rust. I think Rocket is probably the things that comes closest at this point in time, although that's like fair amount of mileage to go to actually claim that is the same. So Optics, going back to the question, is been around for a long time. It's production hardened, like it's being used in multiple applications. It has a fairly good ecosystem. So although it does not provide a lot of things bundled into ActiveSwap itself, there's a lot of community crates that plug into ActiveSwap to provide the things you need. So authentication, sessions, caching, all these things, middleware, scores, all these things can be found on crates.io and just being brought in. That's not the same as having first-class support, but it's very close second. And none of the other web framework at this point in time at that level of ecosystem. So like Warp is nice. There are things I don't like about Warp, especially compile times and like the type errors that you get. I don't think it's particularly beginner friendly, but it doesn't have the same level of ecosystem. Rocket was for the past year and a half running on like a branch without a release version. So it's not an option if you wanted to do something that ran in production. And so that left that with Optics. And we've been happy with it. Like, there are things that are a little bit not as ergonomic as we'd like. I think the middlewares are a bit tough if you're a Rust beginner, but it's been running without an issue. Now, the ecosystem is evolving, and so new options are coming. So Rocket's finally cut a release candidate for 0.5. Looks quite stunning. So it's something I want to look once they actually cut 0.5 past the RC. Axiom has come out in the Tokyo project, which looks very much similar to Optics, with slightly more modern take on some of the APIs. It's built on top of Tower, so it uses a lot of the Tower ecosystem for middlewares, which is the same ecosystem underpinning Tonic, which is a gRPC web framework. I feel like that's like more stuff coming into the full stack corner, so people trying to tackle the fact that you might have a front end and a back end, both written in Rust. I think the project is called Moonzoon, if I'm not mistaken. So things are happening, and I think if we look back 1 year from now, we're going to have a clearer picture of what's going to stay, what's going to go. But of course, like when you're trying to build something, you make a judgment call at the point in time where you need to write the thing. And so for us, at that point in time, ActiveSwap was the best choice. That might not be the case 12 months from now.
What about Warp, though? So I think we were talking earlier in this podcast, or just before we started recording, and I was kind of curious what you think about Warp, because it seems like that one is also getting pushed quite hard. At least that's just my opinion from somebody who's still getting into Rust at this point.
Mm-hmm. So Warp is a nice framework. I don't personally love it, but that's mostly around what APIs you like and find ergonomic. I think what I appreciate in a web framework is structure around the way of doing things. And for me, Warp is too flexible. It leaves you a lot of choices, which is a lot of branches you can add yourself to. And also there's the heavy reliance on the type system, which from time to time gives you fairly complicated type errors. And come to it like from the point of view that I had back in the days, which was most of the people who are going to be working on this are not coming from a Rust background, like they're not Rust programmers. So how can I give them the best experience possible and onboard them as fast as possible? I don't want them to be confronted with half a page of like type breakdowns when they like mistakenly type something in the wrong place or don't tie things together in the right way. So for me, Warp was not an option. I think if you are an advanced Rust programmer and you know your way around the compiler and you're not afraid of like dealing with a bunch of like pretty scary looking Rusty error, then it's something you should be looking into. But it's very much a matter of API preference. In the end, they're both built on Hyper. So the HTTP server underneath is the same. So it's what type of API do you prefer? That's what it boils down to.
So I'm kind of curious because it seems like Hyper, like you said, a lot of things are built on Hyper. Is it going to be a situation where it's like if I remember, I don't know if you ever played with Ruby before, but basically as long as you're rack compatible, then you can basically run whatever. Is it similar kind of thing where if you're Hyper compatible, then you can just start bolting on different applications onto Hyper and then you're ready to go?
So I'm not familiar with Ruby, but there's a similar thing in Python as well. I think it's not about being Hyper compatible in the sense that Hyper is not part of the public interface of these web frameworks. I think it's very much a tactical decision from the point of view of the people writing the web frameworks. It's a lot of work to write a very good HTTP server. There's a lot of things that you need to be aware of, supporting different HTTP standards, like 1, 2, potentially HTTP 3, making sure it's secure, making sure it's performant, making sure you're handling various quirks of historical implementations which are outside of the RFCs, and so on and so forth. So if you have a limited amount of time, which is always the case, and you have a great idea for the API you want to offer your users for your web framework, more often than not, it's a better investment to shop for the actual HTTP server, build on top of it, and so you actually get to deliver what you want to deliver. And then eventually, potentially, down the line, if you think there's something you could be doing better, then you go in and rewrite or substitute the HTTP server implementation. But in most cases, that's fine. I mean, that's not always the case. There are examples of people not using Hyper. I'm not sure. But I think Tide, another web framework, which has a very nice API and is built on top of Async Stud, was built on top of Async H1, which I'm not sure if it's using Hyper or not. But I think that's the only one that comes to mind, which is outside of the built on Hyper trademark for Rust web frameworks.
Yeah, going back to your thing about Python, that's exactly what I'm talking about. So this is as you can see, a lot of these questions are from me because, like I said, I'm still getting into Rust, and so I appreciate this moment. I'm sure I'm not the only one. I don't think everybody's using Rust for web. Well, I have a question about Hyper, right? So actually, our last episode, we did interview Daniel Stenberg, who is the creator of curl. And as you know, curl is starting to use Hyper. So if you're building, if these web services or these web frameworks are building on top of Hyper as a server side, Hyper can also be used as a client side. So is there just many pieces of Hyper? Okay.
There's both a client and a server. So depending on what you're doing, you can use one or the other.
Okay, that's very interesting. Usually I think they're usually separated. That's why I'm kind of curious because I never hear curl actually being also a server unless I missed something somewhere.
So I think they're feature gated. I would have to double check, but I guess the TLDR is that they were implementing the HTTP standard, and so they implemented both sides of it. And so if you're building an HTTP client, you use the client side. If you're building an HTTP server, you use the server side. Now,
when you're using Hyper, do you actually have to put a proxy in front of it, or you can just use it straight?
I think you can use it straight. So that's what we do for ActiveWeb. We don't front it with an Nginx reverse proxy or something similar to that. Then, of course, it depends on what you want to do and how confident you are in doing certain things. So where do you want to terminate TLS, for example? Do you do it in the application? Do you want to delegate that somewhere else? And so depending on the choice, you might still want to use a reverse proxy. But in terms of performance, we haven't had any issue with serving requests straight from ActiveWeb.
Are you using just HTTP 1 or did you switch to 2 or 3?
3 is definitely too early for us. We're using HTTP 1 in most places and HTTP 2 when we're doing gRPC, but that's mostly using Tonic.
Okay, so Tonic is, you said, a gRPC, right? It's works gRPC.
Yeah, gRPC framework, always from the Tokyo project, more or less.
All right, that's cool. Yeah, because actually I don't know anybody using HTTP 2, so it's pretty good to hear. Did you find that easy to work with and set up?
No, absolutely not. It's a nightmare. Like HTTP2, it's great from a performance perspective, but load balancers are not aware of HTTP2. And so it becomes tricky to actually get load balancing to work. There's actually an article that we published, I think, a few months ago on some library we wrote in Rust to add client-side load balancing to Tonic, which is what we use when we need to call gRPC servers internally in Rust, because we run on Kubernetes, and our Kubernetes does not natively load balance HTTP2 connections. We don't have a service mesh, and so we're like, okay, how are we going to load balance these things? And so we wrote a client-side implementation, which uses pieces from Linkerd and the Tower ecosystem, in particular for the load balancing algorithm. But yeah, I wouldn't define that a walk in the park. Requires like HTTP1, you don't think about it. You just start making calls and they get load balanced automatically and everything works. HTTP2, it's a little bit more laborious to get started.
Wait, so you're using HTTP2, is it outside facing or only within your Kubernetes?
Only only for internal calls.
So how do you handle like the certificates between them, or you just use the internal certificates that I think that Kubernetes gives you?
You mean for TLS?
Yeah, because your HTTP2, you have to have HTTPS, right? You can't just run H2 without HTTP.
I think you can run.
You can?
Okay. You can have insecure connections, but I mean, everything in our cluster runs on HTTPS connections, so we sign certificates internally.
Oh, I thought HTTP2 requires HTTPS. That's why I was pretty curious about.
No, I'm fairly sure you can add a fantastic dash insecure to most tooling and run without a TLS certificate.
Maybe it's just self-signed or something. So it looks like HTTP2 is only encrypted. It has to be encrypted if it's through a web browser, but if it's not, then I guess you can be unencrypted, which is interesting. Makes sense. That's what I just read very quickly. Okay, that's new. Today I learned. Yeah. So okay, that's pretty cool. So, and then I guess you must be terminating your TLS on the outside, right? From Nginx proxy.
No, we continue doing TLS throughout the platform.
So you have a cert manager running, and then you just recycle your certificates whenever you like restart your pod or something, or how do you handle like certificates from within your applications?
So no, that liberty of discussing security details of our setup, unfortunately. But yeah, we handle everything internally.
Okay. So what has been like one of the most complicated bits that took like the most amount of iterations or thinking or research to actually get solved that you would consider?
You mean in general using Rust as a backend language?
I would say in your experience of using Rust as a backend language, what's kind of the most complicated and took like a lot of iterations to really get it quote unquote right, or maybe you didn't actually finish it yet?
I wouldn't point to anything in particular. I mean, there are areas where we spend a lot more time than others. For example, we're heavy users of RabbitMQ and general like MQP messaging. And Rust has Lapan, which is an awesome library developed by Clever Cloud, which provides you an implementation of an MQP client. But that's pretty much where it ends. Like there's no ecosystem, there's no frameworks on top, there's nobody else building stuff for it, apparently, or at least if they are, they're not publishing it. So that's an area where we invested significantly internally, and we have our own framework built on top, a bunch of helpers and things that we're using. We're planning to open source at a certain point in the future. But overall, I think the big difficulty that you have at the moment is navigating the ecosystem. So looking at all these things which are moving fast, some are new, and saying, okay, I'm going to use X instead of using Y. And this is like why I'm making this like judgment call here or this judgment call there. And just assembling what is available into a toolkit which can be productive. So like constraining the choice space to the point where somebody that needs to do something knows that they need to go for tool X. There's like very like clear documentation how to do the things that they need to do. There's clear documentation how to test it, and there are examples of this being done before. And so they can go and do it. And that's what we've been like working on quite extensively. It's like making sure that we're building like a platform that developers can use productively. And so they're not every single one of them like reinventing the way we like do tracing for HTTP request or tracing for gRPC calls or authentication and validation of JWTs, and so on and so forth. So it's building your own ecosystem, if you want, on top of the externally available one, which is a smaller and constrained version of what is available in the public.
Have you guys ever considered to create like a generator that can just generate like a boilerplate thing similar to, like you said, Rails, if you bring in a new Rails project or a new Django project?
So we have one. We actually do have one for some of the things we do. The issue I have with generators in general is the generators are purely template-based. So like you have this beautiful thing which is going to spin up a project and like the right folders and the right like function names and so on and so forth. But then it's very difficult to evolve over time. Like my dream, which I don't have time to pursue, is something a la like Elixir with mix and making sure like the stuff gets generated correctly. But then over time, you can also keep making sure that it adheres to the same structure. So refactoring, being aware of what the types are. And like if tomorrow we decide that we want a different folder structure, then we can migrate all the project automatically. Because otherwise what you have is like templates solve the day zero problem very well. So I can get you like up and running really fast. But then day one, day two, when I need to actually maintain all this code, then it's very manual, which is not amazing. So we prefer to rely on libraries because they give us like that support for day two maintenance, and templates just for like the boilerplate stuff, like manifest for deployments, Docker files, folder structures, pretty much it. Because templates are not easy to maintain. Like once the project has been generated and people are actually working on the project, if that makes sense.
Yeah, no, definitely makes sense. I never thought about it like that. Okay. Have you guys ever looked at using, what is it called? Crustlet? Because you guys are using Kubernetes. You're saying you're staying away from WebAssembly. I think you talked about that before the podcast. But Crustlet is using WebAssembly, right? It's a runtime for WebAssembly on Kubernetes, if I remember correctly.
Yeah, so Crustlet is an interesting project from Days Lab, which I think is Microsoft, if I'm not mistaken, on rewriting kubelets, so the agent that runs on nodes in a Kubernetes cluster using Rust. And it supports plugins written in WebAssembly, which is quite interesting. And I think also allows you to run WebAssembly workloads. I don't remember. I don't think we're that experimental in our Kubernetes infrastructure. So we try to stick to stuff that works. We don't have a burning need for doing that at the moment. It's interesting what Crustlet team has done, mostly because of the impact that has on the ecosystem. So it's interesting to see that Rust is getting a little bit of traction in cloud native per se, which I consider a slightly different sector from backend development. So looking at actually building tools and functionality in the cloud ecosystem. So for example, Kubernetes controllers, that is something. It's validating to see that a project that ambitious chose to use Rust, and then the libraries that they contributed to either directly or by providing feedback. Like, for example, kubeRS, which is the Kubernetes Rust client, or kuberuntime, which is built on top of kubeRS. So that's something we're investing into as well. So we're writing a few custom controllers in Rust. That's an area where we're putting more and more time as we go forward. Mostly because we are transitioning to the point where we have a fairly large developer base internally. So we're crossing the hundreds of engineers. And so there starts to be a significant return on investment in actual investing in tooling. And when you're running on Kubernetes, that usually translates into controllers and operators. And for the same reason that we want precise error handling and errors values and algebraic types in applications, the same very reasons apply in the way we manage objects in our infrastructure. And so that's another area where we're starting to use Rust for a few use cases. And it's going well so far.
For hundreds of engineers, you must have a very big AWS bill every month. So going from .NET to Rust, I guess must have also probably saved you guys a little bit of money too, no?
Oh, well, in terms of compute, most definitely. But the point is that often compute is not a bottleneck in an architecture. Like in terms of like peeling, you often spend way more on like storage, both hot storage, databases, cold storage, network bandwidth. There's a lot more that contributes to that sizable AWS bill. And it's true that Rust runs much faster and like much fewer resources. So That's definitely an element. Is that enough to justify like adopting Rust or a Rust rewrite of a service? Only at a very high scale, which I don't think is where we are at the moment. It's a nice side effect. Let's put it that way.
Yeah, it's definitely a benefit, right? And I'm sure that whoever is looking at the monthly bills probably likes that. I would think, right?
Yes, I'm sure they do. But I mean, like, if you want to zoom in for a second, what we really like there, like, it's not necessarily using less compute, is like the performance profile of Rust applications. Like something that we had a lot when running .NET were like GC related spikes, or like having to factor in the GC when looking at the performance of a service. Instead, if you look at the Rust service, it's usually much flatter. Like your latency profile under a constant load, it's usually the same. So your P99 is going to stay there, your P50 is going to stay there, your P75 is going to stay there. And that's a lot easier to manage. It's a lot easier to like do capacity planning. It's a lot easier to like do auto scaling and setting targets. So from an operator perspective, that's good to have. Even more than the fact that it's fast. Like being fast is great, but being predictable is actually much more important.
Yeah, I do remember Discord came out with an article. I'm pretty sure you've probably seen that one, right? Because it seems like you know Elixir quite well. At least you've definitely looked at it before. And they use Elixir, obviously, for most of their services, but for their highly performant stuff, they look at using Rust. And they actually tore out their Go, right, and replaced it with Rust. Or I don't know how much they tore out, but I wouldn't be surprised if it's all of it.
Yeah, it came out, I think, 2 years ago. And that's exactly like that article delivers the point I'm talking about. Like if you look at the plots from that article, so there's like a first phase where they just did a naive rewrite and then they optimized it. And then, of course, like the Rust one is massively faster. But also, I think, because they changed the way stuff worked. So it's the rewrites are never an apple-to-apple comparison because you use the lessons you learned like in version 0 when you do version 1. So you try to do things better from an algorithmic perspective. But when you compare the latency profiles of their Go service with GC, is the spikiness like the big problem. And that's what they completely removed in the Rust version.
But the good thing to know, or not the good thing, sorry, but the thing to know about the spikiness, if I remember correctly, they said it was every 2 minutes, and that was because every 2 minutes there was an automatic GC. That is the more interesting part, right? So even if I always heard before that people say, okay, if you don't allocate, you'll be fine, right? So out here, I'm out in Hong Kong, and there's a huge financial market out here, and there's a big market for people who can write very low, I don't know what you call it, garbage Java, right? Low latency Java, and you just allocate extremely small amount, if anything, every time you use it. But it seems like even with Go, no matter how much you allocate, how careful you are with allocating objects, you're still going to hit a GC issue every 2 minutes, at least according to what I remember in that article. And that is, I think, the worst part about using something like this. So no matter how careful you are, you're still going to get hit.
So, I mean, I'm not an expert in Golang, so I'm not going to say anything that the internet is going to prove me wrong about. But there's an argument, like this argument is often made around .NET as well. It's like, okay, well, if you're very careful and you try not to allocate, then you're not going to suffer like very much from garbage collection. The point is that this is true for Python as well, just as reference counting instead of like garbage collection. The language is not designed to make you aware of where you are allocating. So it's extremely difficult. Like you need to be familiar with the internals of a lot of things to actually like say, oh, I don't think this code is allocating. Like you're streaming against the current a lot to write that kind of code, at which point is it even idiomatic in the language you're using? And this is something which I think was a big like issue in the big data community, which like where many tools are written in Java. And like I remember using Spark and getting out of memory errors like continuously. And like it was very, very difficult. Like you felt you were reverse engineering the implementation to realize, well, actually, if I use this combinator instead of this other combinator, or I change these things around, then this is not going to allocate. So things are going to be okay. But all of this was inferred. And those details could change from like one version to the next. Now, it is true for Rust as well. Like, depending on what you're using, like rates might be more or less careful with allocations, but there's like performance and cloning and costly operations are a lot more in your face when you're writing things. And so it's easier to pay attention to them, almost to a fault. Like when you see the beginners trying to use references everywhere because they don't want to locate. And that you do this every 2 nanoseconds in Python, you just don't see it. Like everything is wrapped in an ARC. So just clone, get the stuff to work, and then potentially afterwards you can refactor it. But it's a symptom of the fact that it's a lot more visible. And that means developers tend to notice more. And there's a culture around it, which also helps.
Yeah, it's funny because when I'm running Python or anything else, I don't really think about and care about allocating objects. But when I am writing Rust, I do feel a little bit worried. Like every time I do a .clone, I just kind of shudder a little bit. Like, ooh, should I be doing that?
Yeah, you feel a bit dirty.
But you're saying I shouldn't even worry about that. You're saying I shouldn't even worry about that. Just kind of write whatever is good and then optimize if I need to.
Yeah, I mean, let's talk about the simplest example, right? Which is backend development. Most services are going to be bottlenecked on RPCs. So remote procedure calls into other services, being those APIs or being those databases. So that you're saving a few milliseconds of not cloning a string, it's likely going to be irrelevant in the grand scheme of things if it takes 50 milliseconds to query your database. Now, if you are cloning a massive amount of JSON on every call, that will eventually show up. So that's something you need to be careful about. But that's why you want to do benchmarking and profiling, so that those things do show up. But the micro optimization, more often than not, you can just forget about it.
All right, I'll try to do that. I still feel dirty every time I do .clone because I know it's making a copy as opposed to just pointing to a reference. It's going to be tough, but I'll definitely try it. Yeah, okay. It's pretty cool. Overall, how has the process been actually writing a book, right? Because it's tough, right? I mean, you actually have to sit there and just write. I mean, do you plan to say, okay, this day I'm going to definitely write, or is it just whenever you feel inspired or just whenever you have a second, or how do you usually write?
I think I've tried all the strategies over the past 12 months, some more successfully than others. A joke I tell a few times is that everybody wants to have written a book, but nobody wants to actually write it. And you realize it's taxing, I think, from a psychological perspective, because it's a long, long process. You're not going to be done soon. It's not something you can cram and say, okay, I'm going to spend the weekend and I'm going to make massive progress. That's not the way it works. And so what I'm trying to do now, succeeding to an extent, is just making sure to show up every day and just write half a page, fix a typo, refactor a section, and compounds over time, and that makes sure that it keeps going. Another thing that helps, and that is specific to zero to production, is that I've been releasing the book chapter by chapter. And so seeing the different chapters being discussed and just in general being appreciated is, of course, a way to boost a little bit morale and saying, okay, I'm doing something that matters to some people. I think it's a lot more difficult if you're spending 2-3 years in a corner writing a book, hoping that when you release it, it's gonna go well. I think that the psychological stress there, it's a lot higher. I'm now in a position when I'm okay, I've wrote a book. It's not finished yet, but it seems it's going well. So I'm just about closing, putting in the work required to cover the last 2 or 3 topics that I think are important. And so it feels I'm approaching the part of the effort when we're sliding towards the closing line, which I hope is going to be by the end of this year. But I've said that already around June of this year, so I'm not going to make any promises. Do my best.
So I kind of think this is your writing is almost like when you create software. It's should I create a feature, aka write a new chapter, or should I fix a typo or fix a chapter? It's tough. I guess you just kind of choose whichever one's more inspiring.
Well, the typo is the rule of thumb for me is the stuff that can be easily addressed. I try to clean up before doing a release. So I've read a new chapter, then I set aside 3 to 4 days just to clean up a bunch of things that have been reported, and then I put everything out in one go. Then there are cleanups which are a bit bigger. So while I was writing, Actix released a significant amount of breaking changes at a certain point, which of course invalidated a bunch of like code examples throughout the book. I think I had to retouch 4 or 5 chapters quite significantly. So I was like, okay, I need to set aside a few weeks because that was about correcting all the code examples and then rereading the chapters to make sure that the text and the reasoning around the code examples made some sense. And it was not exactly the funniest activity, but I mean, you get it done. Because eventually what happens is that people start reading the book, they pull in the latest version by mistake, and then they're like, why does this then not compile? I'm like, well, actually, you're not using the version which is indicated in the book. And after you say that for the 6th or 7th time, then you say, okay, I'm just going to fix it. And so things are kind of easier that way. You got to balance it.
Yeah, that's kind of annoying. Like, I think a lot of people who come from C and then go to Rust, it's like they're expecting kind of long-term stability. But you just don't really get that with Rust, right? With Rust, you have more of a newer kind of like high churn, right? High things changing.
Well, the language is very stable. It's the ecosystem of crates, which is more high churn. Now, I didn't do myself a favor by using a beta version of Arctic Web for the book. So I was in for some pain. I knew that. But I think I thought it was better to go directly there than later like rewrite everything for like a major version upgrade. So it's fine.
You did self-publish, right? So I believe before the show we kind of chatted, and you're actually looking at getting a publisher. Are you regretting not getting a publisher? Are you pretty happy with the route you're going, where you're basically self-publishing, and you're just kind of reaching out and getting lots of feedback from people?
So at this point, I'm not even looking for a publisher anymore because the book is basically finished. So I was looking for a publisher around half of the book. That I think was the sweet point, but I didn't manage to find one. So like, well, let's just go without. Self-publishing was a risk, for sure, because publisher provides you, at least in my mind, I have not published, but talking to other people who did, technical reviewers, so that they ensure that the content is well done, correct, and also in general reviewers that ensure that it's readable and the prose flows, and so it's pleasant to read. Provides with typesetting and just in general everything related to the publishing and the quality of the publishing artifact. And third, and most importantly, provides with brand recognition. So something published by famous publisher A, it's good by definition because it's coming out of famous publisher A. And it provides you with marketing. So they have channels and people who trust the brand, and they're going to push the new title to all of those channels, which usually makes it much more likely that the book is going to sell. At this stage, I went for self-publishing because it was a project I was doing on the side. I wanted to validate that it was working. So at the very beginning, the first few chapters came out as a blog series. It was not even a book. And so at that point in time, I said, okay, let's go with self-publishing, and then we'll find a publisher eventually. And the fact that the chapters are coming out for free, that are building an audience around the book, which was the major risk. The major risk was like releasing a book after 2 years and like flare up for a day and then like being forgotten forever. Instead, publishing it on a schedule, more or less regular, and making sure that the content was available both for free and in a paid form, allow people to consume the material and actually like trust the fact that it was high quality. So I'm gonna go on the blog, I'm gonna read like one chapter. This looks something like well done. I'm interested in this topic. Then I'm gonna buy a book to sustain the effort. And also make sure that the content was circulating more widely, and in turn that the name of the book was circulating. And that made it so that at this point, the book is pretty self-sustaining from like an economical perspective, in the sense that even if nothing is happening, so if I'm not talking about it or I'm not publishing new chapters, a certain number of sales on average always arrive on a monthly basis. And of course, and that's the benefit of self-publishing, 100% of that is coming. It's going into my pocket, taxes not considered, compared to royalties on a published book. So even if it's selling most likely a lot less in terms of like absolute number of copies, probably in terms of economic return, I would argue that it's working in my favor to self-publish compared to publishing. And if I was in a different situation personally, like this would be, for example, a way to self-sustain open source work. because it's coming to the point of being a way to like a monthly salary you could live off, which is fairly impressive considering where it started from. So no regrets. I think in the end, no regrets about going the self-publishing route.
Now, I do have another question. I think this is, so you started writing this book quite a while back. Now you have Rust edition 2021 to take a look at. Do you plan to rewrite everything using 2021? Because this is 0 to production, right?
So it's actually very, very easy. So when Rust editions are different from versions, so to say. So Rust editions are a way to introduce in an opt-in fashion changes into the language, but they do not affect which parts of the ecosystem you can consume. So if your project is using Rust 2018, you can pull in a dependency using Rust 2021, and you can pull in a dependency using Rust 2015. So they're fully interoperable. Now, Rust 2021, from the point of view of the language you write, doesn't make a lot of changes. So it adds a few more items to the prelude. So the items that are always in scope when you're writing a module. So that's easy to change. The thing that it actually does, which from my point of view is a massive boost in terms of like usability, is it changes the way closure capture arguments. So before, if you were calling an anonymous function, so a closure, and in that closure you were capturing a field in a struct, then from an ownership perspective, the closure was taking ownership of the whole struct. So if you had something like my object with like 30 fields and you had a closure that needed read-only access to one field, then suddenly that was taking ownership of the whole struct. And then you had to do cloning and a bunch of things which were a bit ugly. Like there were ways to work around the problem, but it was not as fun. And now edition 2021 instead changes the semantics of captures for closures. So they're going to do partial capture. So they're only going to capture the field you're actually using inside the closure. And that makes it a lot nicer. Those are pretty much the only two big things that I'm aware of, which are going to have an impact on the way I write stuff. So as soon as it goes out, which I think is in a month or two, if I'm not mistaken, I'm just going to do like mass updates of the whole book. That's pretty much going to be it. But generally speaking, like the idea is to keep the book up to date. So even when it's finished, it's going to be a living artifact. So if tomorrow the way of doing configuration significantly shifts because we find a better pattern that is objectively better, then I'm just going to change it. Like it's fine. I put that into account when writing the book.
So that's a pretty big endeavor. Well, I guess once you finish everything, it shouldn't be too bad, right? It should just be little changes here and there for the most part, unless there's a massive change. Like you said, we're using the beta version. So I want to just talk about the general community. This is kind of part of our wrapping up is like, what do you think about the state of education in Rust, right? So obviously, if you're coming from writing this book from 0 to production, do you feel like there's actually enough material that people can just get along and like you're not really, just reaching out and just trying things and figuring out the right way to do? Or do you feel that, you're just doing that exactly, just kind of trying things and seeing what works?
So I think Rust has great beginner material. And that has been true for years. So the Rust book is the prime examples, but then we have different publications in the same spirit. So if you want to come into the community and learn the language, a massive amount of effort has gone into making sure that you can pick up the language in the best possible manner. Now, what Rust, I think, was struggling in terms of like learning ecosystem was taking the next step. Like if I've read all the beginner material, I have a good understanding of the language, how do I get a more in-depth understanding of the language? And how do I understand how to use the language to do X? So how do I use Rust in this specific context? Those are things that I think the ecosystem was lacking for a few years. And this is what I see happening now. Like it seems like we shifted gear and we're like, okay, we know that the bases are solid, and now everybody's focusing on the intermediate and advanced use case. So that's 0 to production in the web development space. That's Rust in action for system programming. It's like, okay, I'm going to teach you Rust, like intermediate advanced fashion. And I'm also going to teach how to use it for doing system programming. And I'm going to teach you concepts about system programming while I do it. Then there's Rust for Rustaceans, which instead takes the language to the advanced section. So we're going to go into the depths of how the things actually work and go way beyond what the book covers. And this is for like people who want to get really good at understanding nitty-gritty details. And so I think we're going to see more of that as we go forward. And that's a healthy symptom, I guess, of a language becoming mainstream and actually people feeling the need of having to learn how to do certain things using it. And then eventually creators or people active in the ecosystem stepping up to fill in that void. So it's looking good. It's looking good. The outlook is very positive, in my opinion.
Fantastic. I didn't actually look at it that way. To me, I thought Rust in Action was more of I didn't think it was more intermediate. I thought it was more like beginner still, because I started reading it and it seemed like it was a little bit beginner. In fact, that they kind of walk through a lot of syntax, but maybe.
So they teach you the language along the way. So you made a different choice from what I made in Zero to Production. Zero to Production doesn't teach you the syntax and the basics. So that's kind of assumed. And we point to the book in the relevant sections. It's like, okay, if you want to know what a trade is, go here. Team has made a different choice. So it tries to teach you the language along the way. But it's definitely like scoped to a particular domain. So it's about system programming, which I think is why the book is particularly interesting. It's like why I found it interesting, for example, because it taught me things I didn't know on top of like teaching me some stuff about Rust.
I think there's an actual system programming book. I mean, there's practical system programming. And there's another one that was just announced recently. I think it's still in beta. Safe systems programming, maybe. I don't know. But there's just intense. It's like there's just an immense amount of Rust books coming out recently, which is pretty good. I think the last question I have is there any tips or warnings you would give to beginners? I mean, because that's who's basically your audience, right? So is there anything that you want to like state right now to them?
Well, I'll go back to what I was suggesting before. So when you're starting out with Rust, it's very easy to get lost in the little details. And so trying to do things pixel perfect and like references everywhere and finding the most idiomatic or like abstract way of doing things. Rust is a broad language. There's a lot to offer and there's a lot of things that you can get lost doing. So I think at the beginning, what you really want, you want to get into a positive feedback loop. Like you want to get to a state of mind where you're trying some stuff out, you get something to work, and then you refactor that something to make it better. But you need to get it to work first. Otherwise, it's very easy to lose interest or just in general, like say, okay, this language is too complicated. I'm not going to do this. So I would suggest beginners to definitely like keep the eye on the prize, which is using Rust to do something. And then in the process of doing that, they're going to get good at the language. And you're going to explore different parts of the language depending on what you're doing. Learning all of Rust is not the goal, also not particularly practical. Like there's tons of things I don't know about Rust, and I've been using it for 4 years at this point. Like there's areas of the language I barely ever used. Like I never wrote an FFI module. I don't know how to write C wrapper because I never had to. Like if I had to, I would go and learn a bunch of documents and potentially I'll learn how to do so. But I don't feel like I need to do so to say that I'm competent at using Rust, because I'm competent at using Rust in a niche, in a specific vertical. And that's more than enough. So the goal is getting stuff done, not learning the language, if that makes sense.
That's a fantastic tip. And that's something I also follow is if you have a goal or a project that you want to focus on, that definitely helps because, like you said, actually, I want to talk about something else for a second is like, so I do a lot more Flutter for my daily work. And a lot of people are always asking for like a Flutter roadmap. I don't know if there's the same thing that people are saying in the communities that you're in, like in your book community on Discord, saying, is there a roadmap that I could follow? To me, I think it's not, I just think it's not a good idea because, like you said, you may not ever use those things. And so you're just kind of learning stuff that's just kind of pointless. But at the same time, there's also a reason that you should learn data structures, right? Maybe you don't use every single type of data structure in the world, but if you can kind of get an idea about what's possible and what's used for, then maybe someday you'll find a very strange use case where you're like, wait a minute, I know what would be good, and I need to go back to that data structures book to find the exact one. So I think that's another way to also look at it too.
Yeah, I think like roadmaps are useful, but I think roadmaps as in like this massive like mind maps, we just say, okay, security or like IDC. Now you need to learn about SQL. It's like SQL is huge. Like, what do you want to learn about SQL? The book, in a way, is a roadmap for web development. Like that's the concept, but it's just put it down into something concrete that you can actually do. At the same time, I agree with you. Like there is something about just exploring without any specific goal in mind, and then those things very serendipitously, like coming back to you at the moment of need and say, well, actually, I remember having read about this algorithm at that point, so I can use it here. But I think that's something you should be doing after you've got the basics covered. And for those type of things, for example, following This Week in Rust is a great like way to stay up to date on what is happening in the Rust ecosystem. And so you might skim or read a couple of articles, and then when you actually need them, you're like, okay, well, I remember about this. I've read it somewhere. You go and you find it out again. And so it's in your back, like it's in the corner of your mind, and you can go there if you need to.
Yeah, definitely. I think we're in line on this part. Okay. I don't think I have anything else. I mean, I really, I feel like I use you for my own learning. As you can see, I'm still picking up stuff. But in general, I think, I love to hear from you, and it's good to hear what you think, because everybody has their own ideas. Is there anything else you wanted to talk about or to kind of plug or anything else going on?
No, I think we covered most of what I've been doing. So pretty much just thank you for having me. It's been a pleasure to chat, and best of luck with the podcast.
Thank you so much. And I please apologize for any of my noob questions, but again,
no, there's no need to apologize.
I'm still learning, but I do appreciate you explaining things to me. So, and I'm sure I'm not the only one. I hope I'm not the only one. So again, thanks for coming on. Maybe we'll invite you again in the future. Maybe when you finish your book, you can kind of talk about how much of a fun or much of a pain it was, right? Or maybe it's going to be like if your significant other gave birth and, how much that was painful, but at the end, maybe they want a second child, right?
Yes,
Something like that.
Like, it was very painful, but we're doing it again. I'm like, okay.
Yeah, exactly. That's the part I never really understood. But anyways, again, thanks for your time. I don't want to take up too much of your time because it's a working day for you and I'm going to head home. So thanks again.